So to find the mean, we're adding them all up. We have plus 10 plus 3.8 plus 6 plus 7.1 plus 1.9. And then get a total. And then what do we do?
Divide by the number of how many.
Yeah, so how many were there? 1, 2, 6, 7, 8, 9. Divide by 9. Is that right? Yeah, that's right. So 5 point, now, chances are that's not going to be an answer if it's multiple choice, right? So what is the answer probably going to look like?
5.38.
They're not going to round it. They might, but I doubt it. What I bet is they would have that as a fraction. So do you remember how to turn a decimal into a fraction in your calculator? What do I hit?
Second.
No.
Math.
Right. No.
Enter.
It's the number 1 fraction. So it's kind of an ugly fraction still, but 242 over 45 would be the fractional answer there. Okay, and then number 2 says, to predict the outcome of class president, which sampling technique is most valid or non-biased? What does it mean to be biased towards something?
If poll only certain people.
If you poll only certain people, Avery, what would you say? If you favor one side, if you make it not fair in a way, or you try to influence it, it makes it biased. So which one seems most valid, the best way? So poll student says they enter the library. Ask 5 random people from every class during 1A block. Or pull everybody in your 2B class. What do you think? Which one seems best? B, I'd agree with that. What's wrong with A? Poll student says they enter the library.
They're all book readers.
Yeah, they're all book readers. Ugh. Book nerds. Go ahead and sign over there. They're all the same. Not necessarily the same, but it's kind of a group of people that obviously all hang out at the library or all check out books. What's wrong with C? What's not the best about C? Yeah, it's literally one class. So if, let's say your 2B class is art. So you're asking all the art kids who they're voting for class president. Is that going to be the same as all the football guys? Yeah, not necessarily, but that's definitely not the best way. So 5 random people from every class, and everyone has a 1A block. So it's like going to every class in the high school and asking 5 random people in every class. Seems like the best option there. All right, so this is the first thing on your notes. So go ahead and take a second and read kind of the little introduction, the first few lines there about dot plots. All right, so what's a dot plot kind of show us? So what do you think? What is a dot plot kind of used for?
Like frequencies?
Good, yeah. How many times does something happen? Or how many people like this? Or how many people like that? Or how many people are this tall? So if I ask you how many kids like the color orange, what would you say? 2. Yeah, so it's a frequency chart, basically. So look at this next one. It says, below is a table of student height in inches. Use the data to create a dot plot above the given line. So 60 inches is 5 foot. So 66 inches is like 5'6". Okay, so usually in a numeric dot plot, like this one here, this was like colors. But if it's numeric, we'll order it in number line order. So what I'm kind of putting on here for you is the middle. Okay, so I want you to take a second and kind of create a number line dot plot with these values. So after plotting our data, first of all, what was the most frequent height?
67.
Yeah, 67. So now that it's in a dot plot, it's pretty obvious. What was the least frequent height? 63. Okay. Does anyone know what we call this kind of shape? Someone yesterday knew it.
A mountain.
I'll give you a hint here.
A slope.
No? Have you seen that before in like science or? I can almost say it again. Do it. It's a bell curve. Have you heard that before? Have you heard of a bell curve? So a lot of times with statistical data, there's usually something called a mean, where the middle is. And what usually happens with the mean? It's not the highest. It's the highest frequency usually, but it's not the highest height. But everyone kind of levitates to the mean, right? There's more people closer to the mean. So how many people are 71 inches? Not very many. There's not very many people that are 6, 7 foot. How many people are less than that? Not very many. There's some, but for the most part, all of our heights kind of tend to gravitate towards the middle. So that brings us to the normal curve right here. That's another name for the bell curve. And that's basically what we're going to talk today is about the normal curve. And we kind of talked about or go ahead and read random sample real quick and sampling bias, and just kind of read that. So random sample, a subset of a statistical population in which each member of the subset has an equal probability of being chosen. Okay. So in order for it to be a random sample, what has to happen? What are some things that need to happen?
Has to be unbiased.
Has to be unbiased. Good, and that kind of leads us to the sampling bias. See, these two right here, they kind of go hand in hand. So it says a systematic error due to the non-random sample. So there is a bias if your sampling is not random, okay? And the whole point of a random sample is you have to have a little bit of the entire population. Now, population can be whatever we want. I could be polling people that go to the mall. That could be my population that I'm taking data for, people that go to the mall. But if I only poll people in GameStop, is that a random sample of everyone that goes to the mall? No. So you have to kind of stop by every store or find a fair way to do that. So random sample, you want random from all over. Usually more is better. That's a good indication. And the word random is always good. So it's usually a good idea if you see the word random. And the normal curve is that bell curve shape. A lot of data kind of fits that curve. And it comes from a set of data that's distributed in the shape of a bell. So you'll see this word, the way that data is distributed into that bell shape. So here's some examples. Are they perfect? Is this a perfect bell? No, you can see that one of them kind of jets up here. This one has kind of a gap. But for the most part, the data kind of leans towards the middle, and then as you get further out, it just kind of tapers off. And the last thing we kind of need to talk about vocab-wise is something called standard deviation. You guys heard that word before? No. Vocab. Standard deviation is how spread out things are. Because sometimes it's just like heights between, like 67 inches and 71 inches or whatever. But sometimes it's like bacteria, like hundreds of thousands of bacteria, and that can be really spread out. So standard deviation is a way to kind of generalize how spread out things are and what percent of the population fits within certain amounts. There's only 3 standard deviations. That's kind of important. There's only 3 of them. I don't think that's on here, but. Oh, and also that's a sigma. Practice drawing one. It's like an O with a little Q. That's called a sigma. And that's typically the symbol for standard deviation. So this is on your notes. This is kind of the main point of today. This is the normal curve. And you can see these percentages filled in. Now, for the most part, these are the same percentages you'd see like anywhere. Like if you search on Google, normal curve, this is going to pop up. Okay? So, you can see down here, they have what does that mean?
Sigma.
1, what does that stand for? Good. Yeah, what would you say that's a symbol for? Standard deviation. Okay? This is also considered one standard deviation. It's just the other way. Kind of like absolute value. If I go 5 miles this way, it's 5 miles. But if I go the other way, is it negative 5 miles? No, it's just the other way. So one standard deviation from the mean, it can be in both directions. Are the people that are 68 feet any more important than the people that are 68 inches any more important than the 63-inch people? No. So one standard deviation from the mean goes both directions. So what total percent fits within one standard deviation? Yeah, do you guys get that? Go ahead and write that in. Now there, you can find the standard deviation, but you're not going to have to do that. So I'll kind of tell you what you need to know here in a minute. The next question is, now we're on to 2 standard deviations in both directions. So if the mean is 67 inches, I want to see how many people are within 2 standard deviations of that mean. So how many total percent fit all the way in between the blue line? So out of all the percentages in the middle. So we have 13.6 plus 13.6 plus 34.1 plus 34.1. 95.4. So write that in the second one. Now, what's the most standard deviations we can have? Yeah, there's only 3. And that's what the way it is. There's only 3 standard deviations ever. So from 95.4, add on the 2.1% on both sides. So now we're all the way up to 3 standard deviations. What do we get? 99.6, yeah. Why do you think it doesn't go past that? There it is. Have you guys ever heard of, yeah, what do you think? It's a really, really tiny number. So have you guys ever heard of an outlier before? Remember of an outlier? It's an outlier. Let me ask you this. So if I'm taking the average, so everyone in the class on our last test, let's say everyone got an 80% to a 90% on their test. So everyone got a B or an A. But one person got 4%. They literally just answered one question. What's that going to do to the average? What's that going to do to the average? It's going to bring everyone down because of that one person, right? So let's say most people had an average between 80 and 90%, but one person had 4%. That's going to bring your average down to 70 something. So does it make sense to say that most people got 70%? No, most people got 80 to 90%. It was that one person that screwed it up for everybody, right? So this little, it's called the tails. That kind of accounts for all the people just way out there that don't really participate or doesn't really make sense to the data that we're looking at. They're just too far out there. Okay, so for the most part, 99.6, and I don't know why it's 0.6 on here. This is usually actually 99.7. There's some more decimals on here that aren't showing. I go ahead and put 99.7. 99% of the data fits within 3 standard deviations. So this is called, and you really need to write this out somewhere. This is called the 68, 95, 99.7 rule. That's super important. That's basically the whole point of today's lesson. And unfortunately, that's going to have to be memorized. You need to know those numbers. So how much of the data fits within 1 standard deviation? 68%. Okay. So this is 1 standard deviation. How much of the data fits within 2 standard deviations? 95%. And how much of the data fits within 3? 99.7. Okay. Now chances are on the EOC, I would be willing to bet they're not going to ask you 2 or 3 standard deviations, but for sure you have to have this one memorized. Because everyone, do you remember the practice EOC? There were 2 of them that asked 1 standard deviation. Okay, so we're going to talk about that one mostly today. So let's take a look at our example here. Let's say we have the weights of 1,000 randomly selected kitty cats. And these weights are normally distributed. That's important. If the mean weight is 8 pounds, and the standard deviation is 1.2